So greetings. I like the prayer. Made me think about Einstein's quote that the most unintelligible thing about the universe is that it is intelligible. In other words, the most difficult thing about the universe to understand is that we can understand it. And Albert Einstein always found that to be fascinating. So in talking about what the study of science looks like at a classical Christian school, specifically Trinity, first of all, we call our department the Department of Theology and Science because we do not believe those are two separate issues. We really believe that science was birthed out of theology. So I called tonight's talk two great conclusions from the 20th century, why they matter to all of us. There were a lot of incredible scientific discoveries in the 20th century, a lot of incredible scientific conclusions. We better define the electron. We went into the quantum level of physics down at the atomic and subatomic level. We made great advances in biomedical engineering. This is especially close to my heart because my oldest son has an artificial aortic valve in his heart. Had he been born 15 years earlier, he would have lived anywhere from 3 to 7 days. Now he's leading a full life. He's 30 years old and expected to have a normal full life expectancy. He runs every day and plays music with this little pop band. And so, in fact, they did one of their songs at the talent show the other night. So we've seen a lot of great discoveries, yet why are these two the greatest discoveries? Hopefully by the end, if you don't agree with me, you'll at least see why I think they're so important. So when I'm talking about what it looks like, I thought the best way to do that would be to give you a glimpse into a couple of conflated subjects, which is really conflating several different class lectures. And I boiled them down to one talk, two subjects, multiple lectures in one. And the first thing to know about science here, theology and science here, is that it's taught apologetically. That doesn't mean we apologize for science. A lot of people think the science has to apologize for itself at a classical school because it's supposedly humanities driven. That's not the case at all. Apologetics is just from the Greek word apologia. In the letter of 2 Peter, he said, always be prepared to give a reason for the hope that is within you. That word reason is apologia in the original Koine Greek of the New Testament. And so that's where that idea of apologetics comes from. And so when we look at science, we realize that this is really the idea you find in Scripture as well. If you look at this passage out of John, he concludes his writing. Most people think that, or most theologians think the 21st chapter was probably written later, maybe by some of his disciples, maybe by his own hand. But originally, this was pretty much the conclusion. And he said, Jesus did many other signs, the John is called a book of signs, in the presence of the disciples, which are not written in this book. But these are written so that, what was the reason I wrote about these signs that Jesus did? So that you may believe that Jesus is the Christ, the Son of God, and that by believing you may have life in his name. So we already see that Christianity is not this religion of blind faith, as much as the post-Christian culture would like to say it is. John himself said these signs Jesus did, he did to point to himself. God has created the universe and designed biological design systems, life itself, in such a way that they point to him because he wants to draw us to himself out of love for us. And so the very first thing you'll see is that we teach apologetically here. We teach that you can come out of Trinity with the ability to scientifically defend your faith, as well as doing it from the positions of logic and history and all the other things that go with that. Also, you'll find that we, in the classical tradition, ask questions, right? You see Jesus throughout the Gospels. He often answers a question with a question. And so this is a question we can ask. If, it's an if-then question, a propositional question. If the universe has not always been around, then could it have created itself? What do you think? If the universe has not always been around, could it have created itself? Any ideas? We're playing rhetoric school here. Now you know how the students feel. Only the lights are bright. They can be seen as clearly as the teacher. What do you think? If the universe has not always been around, you know the answer within you. You're just afraid I'm going to be wrong. Right? No. Why? Why not? Could it have created itself? Yeah, there's no it around to create itself. So no, it couldn't. I've had the privilege to minister and teach all over the world, in Europe, in Africa, in South America, in China, in India. And I've been amazed that this very first verse of the Bible is actually more familiar in non-Christocentric cultures. Of course, America is post-Christocentric culture now, but at least there's still a little bit of the fat left. But where they may not have heard of something we take for granted, John 3:16, everybody's heard of this. In the beginning, God created the heavens and the earth. They know of this first passage, and that's because it is such a radical and unique claim. We take this verse for granted, especially those among us who are Christians. Yet this is a unique religious claim. It's also a unique claim of antiquity. If you look at the Upanishads and the Vedas, if you look at the writings of Buddha and post-Buddha Buddhist writings, and you look at Hinduism, there's a cyclical reality to life. People themselves reincarnate. The universe reincarnates or reinvents itself. Sometimes it's specific in the writings, every 4 billion years or whatever. And so we now know from science that's not the case, as we'll see here in a minute. In monotheistic writings, other than the Judeo-Christian writings, that would be Islam. Islam has all these conflicting creation stories. And then throughout other lesser-known religions, there are all kinds of mythological tales around creation. Only the Judeo-Christian text opens up with this very specific claim that there was a beginning to the universe, and the beginner was God. And that's what led us to our question, if the universe has not always been around, could it have created itself? Duh, no. So what is the next question we ask? What? Has the universe always been around? Right? We've answered one significant thing. If it hasn't, then there had to be some kind of external causal agent, right? So that's the next question. Let's look into it and see. So we ask this question now. Why is there something rather than nothing? Again, what are the two broad possibilities about why there's something, i.e. everything, rather than nothing? Two broad possibilities. It's always been here, or it has not always been and now is. Those are the two broad possibilities. It's always been here, the static universe, or it came into existence until the 20th century. The predominant view was what was called a static, stationary, or ever-present universe. Maybe even the laws themselves had to kind of rearrange themselves. Maybe the laws of the universe changed and were tweaked around for some unknown reason over time. Well, that would violate Scripture, by the way. Again, cosmology of the Bible is unique and accurate. In Jeremiah 33, God is making a promise to Israel, and he says, here's how reliable my promises are. They are as reliable as the laws of the universe, which do not change. Wow. So the predominant view until the 20th century was the universe had always been around. It had to be if you were an atheist, right? That makes sense. Because if it hasn't always been around, there had to be a bring-arounder, right? Okay, so let's look at it. So why is there something rather than nothing? Let's look at a graph. Our y-axis is the usable energy of the universe. There's a total usable energy out there, most of it in the form of stars. They're mostly hydrogen converting to helium in a nuclear fusion reaction that you learn about in the month of October during your sophomore year in honors chemistry. And they're able to tell you all about the fusion reaction on the sun. And so eventually all the energy of the universe becomes unusable. Now, by usable energy, we're talking about basically the thermodynamic energy, transferring heat from a hotter object to a colder object. Eventually, everything kind of levels off somewhere between 1 and 2 degrees Kelvin. That's very cold. 0 degrees Kelvin is absolute zero. No molecular motion whatsoever. And so we look at this graph over time, what's happening to the usable energy as all the stars are converting their hydrogen to helium, and then those are fusing into heavier elements. What's happening? Well, we notice now that the universe is actually on a death course, what is called universal cold death. It's the thermodynamic entropy of the universe. And so you could say maybe we're located right about there on this timeline. So remember, this timeline, that represents the usable energy. It's approaching absolute zero. We know that somewhere in the future, the universe will grow cold and dark and dead. Isn't that great news? It's such hope, right? So eventually we get there, we have a little white creature. Oh no! It's the death of the universe. Why do we say, it's cool, my babies? We can celebrate that the universe is on this trek toward absolute zero, or close to it, between 1 and 2K. Why is it good news? Because it sounds like bad news, doesn't it? It's good news because we ask another question. Why aren't we at absolute zero? We're obviously not, because we're in this room discussing it, sort of discussing. Why is it not absolute zero? Yes, why? Why is there still usable energy? Well, how can you conclude it hasn't always existed? What? Well, but how do I know it had a beginning? We're here, yeah. We haven't reached absolute zero because there hasn't been enough time. Is infinity forever enough time? So therefore, the universe hasn't been here forever, has it? Do you see the problem facing the atheist and facing the 20th century astrophysicist? And, in fact, the 20th century physicists in general, right? They now know, through the expansion of the universe, which we're going to look at also in a minute, that we're on this trek toward absolute cold death of the universe. But because we haven't gotten there, we know there hasn't been enough time. If there hasn't been enough time, that means there was some point where time itself was created. Time itself was created. Now, there's another reason we also know the universe hasn't always been around. We also now know the universe is expanding. How do we know that? It was verified just south of here at the Mount Wilson Observatory. Edwin Hubble was doing his work there, and don't worry about being able to read all that stuff. It's basically this. It's the red shift of light. It's very much like the Doppler effect of sound. Everybody knows that. If you've got a steady frequency coming towards you, such as a horn, it's like And as it gets closer, those waves start kind of hitting each other and squeeze together, and it gets slightly higher, and then it starts stretching the waves out. So it goes Doppler effect, right? As it's going away, the sound wave is stretching out, it's going lower. Light does the same thing. See how the prism, the red is the red shift. If something outside of where Earth's perspective is, farther away, has a shift toward the red end in its light spectrum, that means it's moving faster. And what Edwin Hubble determined with the telescope down there at Mount Wilson, what he determined is that the farther away certain galaxies are, the more redshift there is. And therefore, the universe is expanding. Now, this is a fascinating picture because Einstein, another source of irritation to those who wanted to believe in a static universe, it had always been around, his space-time theorems and theory of relativity also mathematically concluded the universe had to have a beginning. But this was unacceptable to Al. He wanted to buy into the static universe theory, so he monkeyed with his own mathematics, threw in some things called the Einstein Constants to try to fix it to where his mathematics could still explain the universe in terms of it always existing. And so even though his original conclusions were mathematically, wow, looks like the universe had a beginning, he started trying to monkey with it. But then Edwin Hubble, that's the one with the pipe there, that's Walter Adams behind him. He was the supervisor of Mount Wilson Observatory at the time. So Edwin calls him and says, Al, you got to come down here and see what I see. And so Einstein now is convinced of the redshift, therefore convinced of the expansion of the universe, therefore convinced his original math before he monkeyed with it was correct. There really is an expanding universe. And so we move into something like this. Oh, my. Universe is, yeah. And so as it goes, Einstein became convinced over time and gave a famous press conference at one of his visits and said this, I now see the necessity for a beginning. Huge statement. Why is it an enormous statement that this last bastion trying to hold out against his own mathematics is, nope, the universe had to have a beginning. Because if the universe had a beginning, it had to have a beginner, because it was not around to create itself. Not being an it at all, it couldn't do anything, so it had to come from an it maker, God. Right? So you start seeing some of the amazing conclusions of astrophysicists and the like. But look at this. The Bible predicted the expansion of the universe. You think any other ancient writing did that? You think any other religion of antiquity did that? These are just a few. It is full of God expanding the universe. He alone spreads out the heavens. He stretches out the skies like a tent curtain. We know the way the universe expands is as if it's like on a balloon. I should have a balloon with me and make little dots on it and blow it up. That's how it's expanding. Very much like there's this expanding tent curtain and all the galaxies are on that great canvas that's stretching out. The one who created the sky and stretched it out. The Lord, he who stretches, present tense, out the heavens. Phenomenal. The Bible predicted the expansion of the universe. And here it's verified by the redshift just south of here at Mount Wilson by Edwin Hubble and others. It's incredible. The cosmology of the Bible is unique and accurate. And so some conclusions that were reached. Any universe that on average expands has a beginning, including a beginning of space and time itself, thus implying what? This is in a scientific paper. Thus implying a causal agent who transcends space and time. These guys are not Christian believers. They're just being honest scientists, saying it can't create itself because it wasn't around to create itself. Hawking himself, along with his PhD supervisor, Penrose. Hawking did his work at Cambridge. Penrose was at Oxford, but they would share supervisors. In 1970, they wrote this groundbreaking paper, The Singularities of Gravitational Collapse in Cosmology, and basically they reached the same conclusion. If mass exists, right, we know mass exists, especially right after Christmas. If mass exists in general relativity, that's Einstein's work, reliably predicts cosmic dynamics. We know it does, by the way. Einstein's relativity work is now more well tested and proved than Newton's laws of motion. So we really need to change Einstein's theory of relativity. I think we should change it to Einstein's law of relativity, or we're going to have to back up and go back to Newton's theory of motion. Because the theory of relativity is actually more well attested. And that's what Hawking and Penrose are leaning to here. When they say if mass exists, general relativity reliably predicts cosmic dynamics, how things move around, the expansion of the universe, then space and time must be created. Implying a causal agent who transcends space and time. Now, very quickly after that, Hawking was like, whoops, what did I say? Right? Perhaps his first wife, who was a Christian, was having influence. I wasn't thinking like a scientist, because scientists are supposed to believe in methodological naturalism, only naturalistic explanations to things. So he started backing up, and now he's saying things like this. Now let's look at the logic of this statement. Brilliant man, we all know that. A lot smarter than anyone in this room, right? Or probably any room on the planet. Yet, brilliant minds can say things that may not necessarily be brilliant. Because there is a law such as gravity, the universe can and will create itself from nothing. So first of all, look at it logically. That's something we do in classical schools. We look at things from a logical perspective. So let's see. Because there is something, the universe can create itself from nothing. Stephen. Because there is something, because there's such thing, such as law of gravity, the universe can create. So he's already saying there's this thing, this law of gravity thing. Law in physics and in science, laws are not things. They are how we describe the behavior of things. So the law of gravity is not a thing of itself. It's how we describe the effect of objects upon one another. The larger the objects, the more they draw objects to themselves, right? So theoretically, when I drop this, yes, the Earth's drawing the pair of glasses to itself, but theoretically the glasses are actually drawing the Earth itself just a little bit, but it's way too small to measure or to make a difference. We can't feel it, right? Well, so the law of gravity is an observation about how things work. There was no law of gravity before there was stuff, because you have to have stuff behaving a certain way to describe how it behaves. Does that make sense to everyone? Are you with me? Okay, are you getting really encouraged in your faith? And if you're an unbeliever, are you like, need to go to the bathroom because you're like really nervous? Yeah? Okay, it's great. I hope so. I love when unbelievers come because it's really cool, because I went to some lectures like this when I was an unbeliever and generally did not sleep well the nights after because I was trying to be an honest, objective scientist. I remember I was doing animal surgery and analytical biochem at Vanderbilt, and they had this big debate on macroevolution and microevolution. And I was so amazed because the guys from the theology department were pro-evolution, and the anti-evolution guys were biochemists. Now, what's going on here? And so Anyway, I was disturbed that night. Okay, so we can see the problem here. The law of gravity is not a thing. It's how we describe the way things behave. You also see something like this from Lawrence Krauss's recent book, A Universe from Nothing. Oh, this is great. Okay, Larry, here we go. For surely nothing. Now, remember, naturalistic physicists, I want to call them atheists necessarily. They may have some kind of religion or something. But naturalists or naturalistic worldview is everything is just nature. There's no need to deal with the supernatural. That's what Krauss is. So he's trying to argue that maybe everything can come from nothing. For surely nothing is every bit as physical as something, especially if it is defined as the absence of something. What? No, yeah, he's a brilliant physicist wrote this. It's real. For surely nothing is every bit as physical as something, especially if it is defined as the absence of something. So if we would sit down with Dr. Krauss and say, honestly, when you're describing nothing, it's not really nothing, nothingness, nothing, is it? And he would be honest and say, no, it's really something, nothing. So is that really nothing? Well, if it's described as not something, maybe. Okay, there is no God. All right, so that's the kind of stuff that's coming out now, trying to deal with this conclusion from the 20th century that the universe had a beginning. But really, you have more honest assessments, such as of Lincoln and Guth. The cosmos, can't possibly be eternal in the past, meaning it can't have always existed. There must be some kind of boundary. They mean boundary of where it existed and where it didn't. Space, time, matter had to be created at some point from an agent external of itself. Now, so great conclusion number one is the universe had a beginning. What is the theological, philosophical implication of this? Pretty obvious, isn't it? Yeah, had to have a beginning. Now, this one of the most well-known astrophysicists of the 20th century, Fred Hoyle, came up with the term Big Bang to make fun of the idea that the universe had a beginning. When Einstein first became convinced, Hubble was publishing his results of the redshift expansion, when the conclusions about the universal entropy leading to universal death, when all this was happening, Fred Hoyle, who was a staunch static universe guy, he said, oh, these people talking about some Big Bang, right? It was making fun of it. So the Big Bang was actually coined by an atheist, not attacking Christianity, but attacking the idea that the universe had an origin. But the problem is, if there was a Big Bang, there must be a Big Banger, right? Clearly. By the way, Fred Hoyle, near the end of his life, recanted his position and said, yes, indeed, the universe did have a beginning. Whether he became a believer or not, don't know. Some of his writings, his obscure writings later in life, he at least became somewhat of a deist because he realized there had to be some kind of external causal agent. Now, conclusion number two. Huge biological information. You probably all recognize that. What is that? A strand of... Look how that's incorporated into our cultural consciousness. Isn't that amazing? How you look at that, you immediately knew that was DNA. You know, it does something really important. I've heard something about a code, and I think maybe it carries in heritable traits and passes green and blue and brown eyes down and stuff like that. And so it's kind of this nebulous little idea. And so what we do in freshman year is learn details about DNA, its structure, how it works, what it accomplishes, because it is indeed a code. Now, this is a very simplified way DNA is laid out. On the DNA backbone, that's the little strands, It's like what's called a ribose phosphate sugar, and our freshmen know how to draw these chemical structures, and they can draw you the full complex of a DNA unit, right? Why do I have them do that when they're not doing it down the road? Because I want them in reverence and awe of the creator of biological information. That's why. Do we need to know this for the test? When they ask that, I say no, but you do need to know it on Judgment Day. So those A's and T's and G's and C's represent what are called nitrogenous bases. That's where the code is carried. So A always pairs across the strand with T. G always pairs across the strand with C. Do you see that? Got A to T, G to C, then you got C to G. Over there you got T to A, C to G, G to C. So they always pair like that. Now every 3, as you're running down a single strand, every 3 code for a specific amino acid. Now don't get bored, don't get mad at me, stay with me. This is important. All right, so there are 20 amino acids, very similar to our 26 letters of our alphabet. Now you have to string these amino acids together into long chains of proteins. So amino acid would be the letter unit. Long chains of them make a protein. The average protein is 150 to 250 amino acids. So it's like 150 letter and space and punctuation sentence to a 250 letter space and punctuation sentence, right? So you have to put these amino acids together in the right sequence in order for these proteins to work. Now, we're mostly water, 70% water or whatever. But if you take a cell and you take all the water out of it and then weigh it, 90% of that dry weight is protein. 90% of the dry weight of a cell is protein. So clearly, they are really important compounds. You build little molecular machines out of proteins. You make enzymes out of proteins, which are these machines. Students in their freshman year learn all about these different kinds of machines, how they have to be wired together, all the way from the light-dependent machines of the photosystems that absorb light, and we build sugar and all this stuff. They learn these details because they're overwhelmed with the fact that this stuff is so complex it couldn't have just thrown itself together all at once, right? Okay, so here's a little code, AGC. That codes for a specific amino acid. Now, before we can get at that code, we've got to unwind the helix. And so this protein comes along, grabs a hold of those strands, and opens them up. Now we've got one strand exposed, AGC, TAA, ATC, on down and down, right? To where you've got, say, 750 of those bases exposed. How many amino acids would that be if it was 750 bases? If 3 bases is 1 amino acid? 250. So that's a typical protein. It would be 750 bases along that strand. So a machine, which, by the way, had to be coded and built from this same code, unwinds it. Some more RNA comes in, copies that code, takes that code out of the nucleus. The helix winds itself back together with the help of other molecular machines. That code, messenger RNA, because it's carrying the message, it takes that code, 750 bases, to the ribosomes, where another type of RNA, transfer RNA, is carrying amino acids. They link up together through this kind of base pairing and string these amino acids together. Now you have this 250 amino acid strand put together as a protein. Another machine takes it from the ribosome, ushers it over to the Golgi apparatus. Inside the Golgi apparatus, other machines come and fold this protein down into its shape it needs to be a machine. Another machine takes it out of the Golgi apparatus. Another machine comes along, picks up that folded functional protein, carries it to where it's needed in the cell, places it there, and then it does its work. All of this is coded in the DNA. All of it. If the amino acids are out of sequence, you won't have a functional protein. You'll have gibberish just like if you threw letters together. See, that doesn't mean anything. But in the right sequence, this has functional meaning. Same with amino acids. I can't just throw amino acids loosely out there. They have to be strung together, and the way they're strung together is all coded inside, sorry, I'm having some trouble here, inside of the DNA. That's why DNA is called the language of life, because it is literally a code, literally a language, a programmed code to code for proteins, which make up 90% of the dry weight of a cell and do all the work within the cell. There are proteins now, we're able to actually see them through this type of electron microscopy, and they're carrier motor proteins. They literally have arms and legs, literally have arms and legs, and they carry things like this. And they walk along these strands of actin fibers and carry things to other parts of the cell. No joke, they literally walk along these scaffoldings. And if you look at a cell, you'll see the scaffolding throughout it. Remember, it's three-dimensional. And you see this scaffolding throughout the cell and all these motor proteins carrying other proteins to where they need to be in the cell to do their thing. It is the most complex bunch of nanomachinery you have ever seen. And all of it is coded in the 3.1 billion bits of information inside of the DNA of every single one of your 100 trillion cells. Now, why do you think information is such a problem for the atheist? Here's what Bill Gates said about DNA. It's like a computer program, but far, far more advanced than any software ever created. Direct quote out of his book, The Road Ahead. DNA information. It's not only incredible from the language perspective, but we also learn in classical education that truth is beauty. There's the famous rose stained glass window at the York Minster Cathedral. And on the right is an actual spectroscopic photograph of DNA molecule top-down view. Gorgeous. Isn't it beautiful? You can see all the little things sticking out there. Those are the bases. You see how the strands work their way down. So you're looking down inside that helix. It's gorgeous. It's absolutely beautiful. And God, I sometimes think about the mind of God. I try not to think about it too long, but because it's scary, yeah. And now we get this idea, oh boy, your thoughts are so above mine. And that he has invited us into this world. I mean, he's known about DNA from the very first time he specially created the first life form. Right? And he's known how beautiful it was. And I just think about the patience of God waiting till humans would kind of get to this point and be in awe of him in a whole new way. Right? A whole new way. We can look into a beautiful night sky. We won't see the night sky Abraham saw. We can see at the best probably 15,000 stars, which is a lot if you get to a good mountain peak somewhere away from air and light pollution. Abraham saw about 35,000, literally a cloud of stars. Now light and air pollution takes that away, but it's still pretty glorious. But we can also look down into a single living unit, the cell, and find this kind of beauty. And so, great conclusion number 2 is biological information. No doubt about it. It is a written code. This became a problem for the naturalistic worldview very early on. An institute was started at MIT to start looking at the language of life. And their conclusion was, you can't mess with the letters of the alphabet and have meaningful sequences. And the same is true for amino acids building proteins, Therefore, you can't mess with the sequence of bases inside of DNA. This is a programmed code. That was the conclusion from MIT way back in the 1960s. And so radical is this discovery that the naturalists are coming up with all kinds of theory to explain the origin of DNA. Francis Crick, one of the founders of Watson-Crick fame, published a paper in 1954, one-page paper in the journal Nature, describing the very structure of DNA. They won the Nobel Prize for that. But he won't accept it. His friend Watson was always saying, I remind my biology students almost every day, remember, this is not designed. Remember, this is not designed. This evolved naturally. He reminded them almost every day of that. Why? Yeah, right? I see this white thing with webbed feet walking across the floor, quacking, and I say, let me remind you, that's not a duck. That is not a duck. That is not a duck. It's not a duck. It's not a duck, right? So, constantly reminding, well, Crick came up with this one. We know enough about the history of Earth now to know that DNA could not have spontaneously generated. Therefore, it had to come from outside of the Earth. So far, we're like, yeah, we're on the same page there. But his theory is some intelligent alien life forms manufactured some DNA in the laboratory suited for Earth and put it into a space pod and launched it, and it landed here, and the first cells were birthed from that. That guy won the Nobel Prize for discovering the structure of DNA. You see what happens when you remove one of the most obvious variables from one of the possible conclusions. Science has this thing called deferring to the best possible explanation. But if deferring to the best possible explanation means an external intelligent creator, and that's unacceptable, then we'll go with what's called transpanspermia generation, this idea of space aliens sending DNA to planet Earth. Really? I know I'm making that up, but it's true. It's true. So what's the philosophical, theological implication of the language of life? Yeah, right? Exactly. A programmed code requires what? A programmer. The guys up in Seattle at Microsoft, or the guys over here in Simi Valley, when they build software, they don't just throw things together. 1001001. No, 100, that sounds really good. I'm going to throw it together and see what I get. I'm not going to pay attention. Let's see. I put in gibberish. Let's see what we got out. Gibberish, gibberish, gibberish. Right? A programmed code requires a programmer. A universe that was created requires a creator. A programmed code requires a programmer. Now, this only takes us so far, but it does remove the barrier of atheism and naturalism. Okay, so now I'll take any questions you may have on this or anything else. So I'm sure you are full of questions. Yes, sir. Yeah, well, yes, there are several theories. Two predominant ones. One's the multiverse. Now, the multiverse theory was birthed out of the fact that not only was the universe created out of nothing, but it's also very fine-tuned. We talked about the universe expanding. We now know there is some force, similar to the force of gravity, only it's kind of an anti-gravity force. We call it dark energy, or the dark energy force, and it's controlling the expansion rate of the universe. It's fine-tuned, now get this, 10 to the 123rd power. That's some precision. The closest we've gotten is a gravity wave telescope. It was a joint project between MIT and Caltech astrophysicists and engineers. And they came up with a gravity wave telescope, and it's fine-tuned something like 10 to the 27th. I'm being generous. It's probably less than that. But 10 to the 27th versus 10 to the 123rd, what that tells you is that God is 10 to the 96 smarter and more well-funded than those guys, right? So the multiverse came about saying, well, maybe there are an infinite number of universes out there. Ours happens to be the one that's fine-tuned. And as one universe dies, it gives birth to another. That brings about this other explanation, which is quantum tunneling. And it's still based on his idea of the law of gravity, right? And quantum tunneling says that our universe is basically, as it's expanding in its parallel next to B universe, there's a collapse taking place. So it's kind of a mirror image idea. And we've done some quantum experiments that on a subatomic level, and they're kind of saying, well, maybe what happens on the subatomic level is happening on the universal level. And so as this universe is expanding, from the perspective of the new universe, it's actually collapsing, and then it goes through this quantum tunnel, and it starts all over again. But there's some real problems with that. First of all, it's not something we can measure. Second of all, it's pure conjecture based on the assumption that there's no God, right? Thirdly, it's based on the fact that the laws of physics are going to be the same. We know God's going to change the laws of physics with the new heaven and the new earth. He's describing, when he describes New Jerusalem, it's so large that the laws of gravity as we know them today, it would collapse on itself, kind of like a black hole. It would be forced into a sphere. So we know God's going to change laws of physics. So that's cool, my babies. We know he can do whatever he wants with laws of physics. But the quantum tunneling model has a whole lot of problems. I have not read the latest thing, but they're going to keep coming out. I mean, you have to keep coming up with things if you throw out a creator. They're trying to go back to a static universe. Well, it hasn't always been around like this, but it has always been around. Maybe the energy of the universe has just always existed. Well, where'd that come from? Well, where'd your God come from? We say he's always been. Well, so has my universe. Oh, so you have a God also. So it's a matter of which God is more reasonable. The God of the Bible, who has always been around and created the stuff, or the stuff itself, which requires an enormous amount of a torturous mathematical convolution to explain that it's always been around, even though we know it's on its way to cold death and that it's expanding. If it had been expanding forever, it would be infinitely large. It's large, but it's not infinitely large, right? And so you pick which God is eternal, stuff or the God of the Bible. God of the Bible is much more scientifically reasonable. Yes, ma'am. Yes, they are. Oh, when cold death occurs? Yeah. Yes. The common model is called the inflationary theory, that it expanded very quickly at first. I can go back to that picture for you. And, whoops, let me go back to that picture. And then I can explain it better. There we go. Let's see here. I'll get this right. Okay. There we go. Okay. So see at the bottom where it says Big Bang inflation. So it started virtually tiny, right? And then expanded very quickly. And then gravity was winning the first third of the universe. So it kind of expanded quickly. Then it starts collapsing. But then dark energy starts winning, and it starts expanding, and it's gradually increasing. Well, that expansion rate, that's what's finely tuned 10 to the 123rd power. If it was any less or any more, we would not have a habitable planet like Earth, right? So, yes, that's where that 10 to the 123rd power comes from, the precision. They can measure it. Is that answering your question? Okay. Well, let's do it exactly. Oh, yeah. It's a long time, like 10 to the 40th years. So it's got a long way to go. A long way to go. Jesus will come back way before then. Now, well, yeah, theoretically, but see, because the expansion rate's increasing, gravity's losing. Once gravity starts losing, it's lost forever. It can't recover because the greater distance between objects, the less the gravitational force. So as soon as it started expanding faster than it was originally collapsing, now you know gravity's lost the battle. Now dark energy's won. There's no way gravity can win now because this has much more gravitational pull than this. That has more than this. So gravity's less and less and less as the galaxies get farther and farther apart, and therefore the cold death of the universe is inevitable. It hasn't happened, therefore it hasn't always been around. Yeah. Oh, what do they say was the beginning? Is that what you're asking? Oh. Yes. Yeah. Theoretically, of course, we know Jesus will come back. God's going to change the laws, physical laws. But theoretically, the stuff will expand forever, but the usable energy will dissipate, right? Now, if dark energy is tied, I know we're getting down the weeds a little, but it's more fun than it's possibly imaginable, right? And as I tell the students, it builds your character. If dark energy is tied into that total energy, then dark energy will quit doing its thing and the stuff will just stay at that particular place. Some people are trying to say, oh, maybe gravity will win at that point, but no way. Everything's just too far apart. Yeah. Yes. Yes, sir.
So I was researching something from that thing and trying to see if there was any evidence for anything out there.
Yeah.
Which ended at YouTube, and there was this atheist talk show where they were talking about that the work that's being done at CERN
Mm-hmm.
actually proven that there is a virtual particle that actually goes in and out of existence from nothing.
Sure.
And then back. So
Yes.
what's going on there?
And well, first of all, the name of that particle is the God particle. So let's get that elephant out of the room.
So they seem to act like something was
Yeah.
not the God particle, but this virtual particle.
Oh yeah. So yeah. Well, and what do you think the key adjective of that is? Virtual, right? So we can make a movie Star Wars and make a virtual reality. Star Wars has some really bad physics in it, but it's fun, good and evil and all that stuff. Although the earlier ones were kind of a evangelical tool for Hinduism, but we won't go into that. Okay, so they're fun. I like them. All right, so here's what we've got. We've got this highly designed, purified magnetic tunnel that's forcing this issue. So they're creating a false reality within this tunnel that in no way matches the reality we observe out there. So can we create a virtual particle that comes in and out of existence? Yes, we can, but so what? I mean, that's the so what. It's very similar to the Miller-Urey experiment. Miller and Urey, in the 1950s, they took certain gases and mixed them with water vapor, sparked it, and made a few amino acids, some of the simpler amino acids. They weren't racemically pure, which means you have to have racemically pure amino acids for them to be functional in the body, nor did they make anywhere near the 20 that we have. But that being said, you can create amino acids in the laboratory, but the problem is the gases that they created these amino acids with were not the gases found in primordial Earth. So it's a virtual creation of some biochemicals, some building blocks of proteins, but it in no way mimics nature. And this is the same kind of thing. We can create these realities, and it's fun to do this. It's great to show the innovation of Imago Dei, that we can do stuff like this. But it has to match the natural world in order to be used as an argument that this can happen in the natural world. That's the problem, yeah. But they just kind of gloss over that. Well, we know we can make this very, in what kind of environment do you make that? Well, a total vacuum with billion-dollar magnets in a 1 mile centrifuge. Oh, yeah, like out in outer space. Right, yeah. Yes, sir.
So, astrophysicists have an explanation, or
yeah.
say the Big Bang, or the origin of the universe, and we might get painted in the corner, but we don't know what caused that.
Yeah.
But this was the mechanism by which the matter of the universe may have been created.
Yeah, Big Bang is more of a description of what's observed rather than a description of the actual mechanism itself. Okay. Yeah.
I'm wondering, is there a similar description, say, by biochemists for the origin or the mechanism of the creation of DNA?
Yeah, there's a whole field of biology now called origins, biological origins. There's a journal that I take called Biological Origins. It's great reading. It's very fascinating to see how one theory comes about and then fails a few months later. So short answer, no, right? The short answer is there's no way nature can blindly create a meaningful code. I mean, I can take a bunch of Scrabble letters, dump them out here, and it's not going to say to be or not to be. That is the question, right? I might get it, or I might get some words here and there, but I'm not going to take the entire letters and punctuation marks of a Shakespearean play and strew them out and then get the Shakespearean play. It's just not going to happen. And the DNA coding is much more complex than a Shakespearean play. So short answer is no, but are they looking? Absolutely. I mean, desperately so. I can tell you Darwinian evolution is being chunked. It's being thrown out. Now, you don't hear this in the news. You wouldn't know it by looking at the textbooks. But everyone is pretty much saying we've got to start over. We must find another paradigm. Because Darwin's methodology, his description is natural selection through gradual successive changes, right? Well, the fossil record doesn't support that, nor does the observation of molecular machines within the cell. Right? You take something like a bacterial flagellum, the little thing that spins around. It spins at 100,000 RPM, 100,000 rounds per minute, can stop on a quarter turn, reverse direction 100,000 minutes like that. This is in the simplest life form we know of, a bacteria. Bacterial flagellum has 40 functional parts. We now have an actual photograph, I wish I had one to show you, of a bacterial flagellum, and it looks exactly like an outboard motor. It has a stator, a rotor, has a proton pump that's driving it. The protons are providing the gears. I mean, it's an outboard motor. Has 40 functional parts. Well, according to Darwin's methodology, in fact, to give Darwin credit, I'm wondering today, I'm not sure Darwin would be a Darwinist. He probably wouldn't, because he said if it can be found, an organ so complex that it couldn't come together through slight successive changes over time, my whole theory would collapse. Those are his very words. And so now we have these 40 parts. Well, you have to put all these parts together at once, and you have to have machines that put these parts together. They have to be assembled in order. So even, say you order a bike, it's the nightmare for Christmas Eve. Santa is putting the bike together with the Chinese instructions, right? And so take the pedal and swallow one, and so, well, not only do you have the parts that had to be made, now they have to be assembled. And it should be assembled in some kind of order and not the order the instructions give you, right? But they have to be assembled properly. Well, same thing with the bacterial flagellum. You got 40 parts, they have to be built together in the right assembly line. So the problem with Darwinian description is obvious, and so they came up with Neo-Darwin. Well, now they're going to have to come up with Neo-Neo, something else. And it is Darwinian. The Darwinian model is on the ropes, for real. But it doesn't mean they're all becoming creationists or Christians. It just means they're recognizing we've got to have another paradigm. So short answer again, no, they don't have an explanation. You just can't. They had this theory called the Rna World Theory, real quickly. It was predominant for a while. It said, oh, maybe some RNA got together. They're like, wait, stop, time out. That's a big loaded sentence. Maybe some RNA got together, because RNA is what carries the message from DNA. So maybe the first cells were RNA because we find some in mitochondria and all this. But it's about gone. There's still some people holding on to RNA world theory, but that was the last good attempt, and it's about gone. So there aren't any good ones out there right now. Yes, ma'am. Oh, boy. Whew. Yeah. Exciting and requiring some Christian ethics behind it, which is scary because we're post-Christian now. We're doing amazing stuff in biomedical engineering at both the DNA level and at the cellular level. I mean, they're able to actually pinpoint certain neurons within the brain now for ALS and Alzheimer's, and they've successfully restored some speech to a man who had lost his speech center. They're doing some great stuff, but we got to be careful because we're moving into this kind of virtual reality. So DNA research is, there's some great stuff that can come from it. We can start now to build our own viruses, and so we might be able to build viruses that attack only cancer cells. I mean, ideally, the sci-fi, which is becoming sci-reality, is you give a person with cancer a shot, they get a bad cold for 10 days and they're cured because this virus has gone in there and eaten up all the cancer. So there's all kinds of really neat things happening, but big responsibilities going on. Some people say you shouldn't even be cloning animals. I think Barbara Streisand recently cloned her dog, and it was big news, and even PETA got mad, and it's funny to see their own arguing. But, you should get a dog from the shelter, and I wanted my Babs Jr. or whatever, So, but I don't have a problem with that. Some people do. But I think it's fun. It's cool. Clone animals. Just stay away from Imago Dei. Don't be messing around with that, the image of God. Others? Well, I hope you're encouraged that science is your friend, because science was birthed out of theology, and trust me, there's nothing coming in science that's going to blow Christianity out of the water. Right now, science is moving so fast, and every move that it makes more and more supports the God of the Bible. Really what happened in the 19th and earliest 20th century is science was running, and it thought it was increasing speed and running away from God, and then slammed into this thing and looked up, and it was God. And that's where we are right now. There are so many astrophysicists coming to faith. There are many, many biologists and molecular biologists and biochemists who are in the closet, and the next generation of tenured professors is going to be interesting. Wait till these people get tenure. Once they've locked their positions in, you're going to see some amazing stuff in the world of science, because it's becoming obvious. It's becoming so obvious that programmed information requires a programmer. And the molecular machines inside of cells. I mean, we learn how some of these machines function, and they're just incredible. They're so intricate. They're so complex. The complexity itself doesn't point to a creator. The complexity itself points to the challenge of building that thing gradually over millions of years. It just can't be done. All the parts have to be there at the same time and assembled to carry out their functions. I mean, and on and on and on it goes. We need oxygen, it kills cells. You got to have this enzyme called superoxide dismutase, SOD. It has to be present outside the cell, inside the cell, and in the cell membrane to protect against superoxide. Yet without oxygen, you got no life. On and on and on it goes. And all of these molecular machines point to the fact that it's an incredible world of nanomachinery inside of there. So be very, very confident. You don't need this stuff to have faith in Christ, obviously, because we have a long chain leaning back to Jesus, and there weren't a lot of molecular biologists during the Middle Ages, right? But it does reinforce your faith. These are signs in nature. That's why the Belgic Confession talks about God's two books. The supreme book, that's the authoritative book, the book of Scripture, and the book of nature. These two books will never conflict with each other. If they appear like they do, we're just misreading one of them, and doesn't matter. Can science inform the Bible? Yeah, but the Bible's the ultimate authority, and it really informs science. It told us a long time ago the universe was created. It told us a long time ago the universe is expanding. It told us a long time ago we're marvelously made. We only understand what that means in the last 15 years as we're looking at these molecular machines. So be confident in your faith, and know also that if you have a child here at Trinity, I can assure you my goal is for them not only to be armed to the teeth to keep their faith when they go beyond Trinity, but actually to be as big a pain to their professors who are atheists as they can be. And I think it's very possible, because they will be well armed. I can assure you of that. Shall I close this in prayer? Lord, thank you for these precious people who took time to come and hear about your glory through the creation of the universe and the programming of biological information. We thank you that it strengthens our faith. We know, Lord, we don't need this for our faith, but we're grateful to you that it comforts us and gives us yet another sign that you are who you say you are. We know the ultimate goal of having these kind of discussions is really to see how much you love us, to see how much you draw us to yourself. That you tell us, if I can tend to the details of nanomachinery in every single cell of your body, oh, how much more can I tend to the details of your life? And we thank you for that comforting message of truth, God. We thank you for being such an amazing creator and such an amazing programmer of life. And more important, that you're such an amazing lover and that you draw us to yourselves. I pray for everyone here, for all the students and family members represented here, and pray that the work of Trinity will continue to prepare these students to be the light of this world by carrying the truth, the torch of Jesus Christ, wherever they may go. And it's in his name that we pray. Amen. Thank you so much for being here.